Hello everyone and welcome to another tutorial. Throughout this video we are going to discuss and explain some 3D problems using Pythagoras rule and trigonometrics. We are going to find missing sides and missing angles, angle of elevation, angle of depression using the trigonometrics and Pythagoras rules in 3D shapes. Here is a good question. In this rectangular box shown, find AC. In this rectangular box, AC is right here. AC is the diagonal of this rectangle ABCD. Now let's just illustrate the rectangle and we see where is AC. Here is A, B, C, and D is right here. What we want to find, we need to find AC, this diagonal. How can we find this? We are going to use Pythagoras rule. As it's given in the question, AB is 12 centimeters and BC is 5 centimeters. So in this right angle triangle, one side is missing, which is hypotenuse. Easily we can use Pythagoras theorem. Let's call this missing side x. Then x square, which is the longest side, is equal to 5 square plus 12 square. Then x square is equal to 5 square is equal to 25 plus 12 square is equal to 144. Then add them, it's equal to 169. X square is equal to 169. How can we get rid of this power 2? By taking square root to both sides. You see, this power 2 will cancel the square root. What's remaining on the sides only x is equal to the square root of 169, which is 13. Now x is 13 centimeters. X represents the side AC, so we just did part A, it's 13. They are all in centimeters, the dimensions, so 13 will be in centimeters too. Now part B, we're going to find AR. AR is here from this corner to here. AR is here. Now we need to illustrate another rectangle because AR is the diagonal of a rectangle which is between AQRD. AQRD is a rectangle and AR is the diagonal of this rectangle. So let's draw a simple diagram to represent this rectangle that we want to work on. Again, it's about rectangle and it's about finding diagonal. Look at this rectangle. If we join A to Q, so here is A, Q is here, and then Q to R, and R to D. AR is the diagonal of this rectangle, AR. Now let's write the dimensions. This one, QR is 5 centimeters because QR is the same length as BC, which is 5. So QR is 5 centimeters. What about AQ? AC is AQ. We don't know how long is this side. So firstly, we have to find AQ. To find AQ, look, for these questions, it's always like this. You look what you need to find. Now we need to find AR. In order to find AR, we need to know how long is AQ. Now, we need to find the length of AQ, then we can go back to this problem and find AR. Now, AQ is this straight line from A to Q. AQ is this line, and we know this height is 4, so it means BQ is also 4. Now let's use Pythagoras to find AQ. AQ, let's call AQ y. Then y square is equal to 12 square plus 4 square. Then 12 square is equal to 144 plus 4 square is equal to 16. Then y square is equal to these. Y square is equal to 44, so it will be 160. And to get rid of this power 2, y is equal to the square root of 160. So let's calculate the square root of 160. Square root of 160 is equal to 12.64. So AQ is 12.64 centimeters. We got the length of AQ. Now we are ready to find AR. To find AR, again we're going to use Pythagoras theorem. Again, we're going to use Pythagoras theorem. AR, let's call this AR P, which is easier to use in the Pythagoras theorem. P square is equal to 5 square plus 12.64 square. Then P square is equal to 5 square plus 12.64 square, which is equal to 184.76. This is P squared. Then to get rid of this power 2, P squared is 184.76. To get rid of this power 2 of the P squared, we need to take the square root of this answer. Then the square root of this 184.76 is equal to 13.59. So nearly we can say 13.6. AR, which is the diagonal of this rectangle, AQRD is a rectangle. AR is the diagonal of this rectangle. Using Pythagoras theorem, we found AR. And the third requirement in the question is the angle between AC and AR. Now we need to find the angle which is between AC. We need to find the angle which is between AC and AR. We need to find this angle which is between them. Now to find this angle, let's see what we have and what can we do. To draw a diagram for this triangle that we see consists of AC, AR and RC. Then let's see the dimensions of the triangle and which rule will be able to help us. Here's a right angle and a straight line. Okay, let's label it. What is this letter? It's A, and here is C, here is R. We just copied this triangle. Then CR is 4 centimeters. AC, we found it in the first part A, it's 13 centimeters. And AR, we found it's 13.6. They are all in centimeters. What we have to do, we have to find this angle. Okay, to find this angle, since we know all the sides, we can use tan, we can use sine, we can use cosine as well. Let's use cosine. All of them will work because we have all the sides we need. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. Whatever we use is fine. Let's use cosine. Cosine of angle A is adjacent over hypotenuse. The adjacent of angle A is 13 and hypotenuse is always the longest side, so 13 over 13.6. Then let's divide this 13 divided by 13.6 is equal to 0.95, and this part of the decimal places is repeating over and over, so it's a recurring decimal. Let's say it's 0.95. What is equal to 0.95? Cosine of A. Cosine of A is equal to 95. Now we must use cosine inverse to get the angle A. Cosine inverse. So while you are using your calculator, it's better to use the answer command, not just writing 0.95, because this answer is not just 0.95. There are so many more numbers after the 5. So we're going to say cosine inverse of the answer is 17.08 to 1 decimal place. We can say it's 17.1. Then angle A is 17.1. Let's try to find this angle using sine. If we want to use sine, then we're going to use opposite and the hypotenuse, and let's see how does it work. Sine of A is equal to opposite, which is 4, over hypotenuse 13.6. Now 4 divided by 13.6 is equal to 5 over 17. Then we need sine inverse of the answer, which gives already 17.1. This is 0. We cannot round this one to 2, so angle A is 17.1. Can we use tan? Definitely we can, and you'll see the answer is 17.1. Let's use tan only in the calculator. So to find the tan of angle A, we will say opposite over adjacent, then 4 divided by 13 is equal to this, and we need tan inverse of the answer. That gives 17.1, which is totally correct. Done. This angle is 17.1 degrees, and these are centimeters. The most important thing to solve such questions, you have to demonstrate the shape that you are working on. Then think when you need to find a missing side, if only one side is given in the triangle, if only 2 sides are given with no angle, then you have to use Pythagoras. But when angles are given with sides, you have to use some trigonometric functions. I hope you find it useful. Thank you for watching.